Hello everyone. Today we are going to start with our next chapter, that is trigonometrical ratios. Now this is absolutely new concept for all of you. I'm sure that you might have come across some trigonometrical ratios earlier, like in the chapter coordinate geometry you came across the concept of slope, and slope had one of its formula as tan theta, where theta was the angle of inclination. So tan of angle of inclination is known as slope. So what is this tan exactly? So in trigonometry we are going to focus on these ratios, tan being one of the trigonometrical ratios. So there are 6 trigonometrical ratios, but before going deeper into trigonometrical ratios, let's first understand what exactly is trigonometrical ratio. And before that, we have to understand what exactly trigonometry is. So the word trigonometry means measurement of angles and sides of triangles. Measurement of triangles, you can call it. So everything associated with a triangle, be it the sides of triangle, the measure, the angles of triangles. So the science or the mathematics dealing with the measurement of sides and angles of the triangle is known as trigonometry. All right. So in this unit, we shall be dealing with relations of sides and angles of a right angle triangle. So let's understand the concept of perpendicular, base, and hypotenuse in a right triangle. Okay. So for our reference, we are going to give them some easier names. Perpendicular, base, and hypotenuse are, of course, known to us. They are not new concepts. But for our reference, we will call the base as adjacent side, the perpendicular as opposite side, and hypotenuse as hypotenuse only. Okay. So let's understand uh, with respect to each angle, what is the perpendicular, what is the opposite side, and what is the what is the hypotenuse, what is the opposite, and what is the adjacent sides. Okay, so here the angle of reference is A. We are referring to angle A. With respect to angle A, AB is the adjacent side, which is known as base over here. Okay, so we are going to call it adjacent side. AB is going to be known as, just a moment, yes, the side AB is going to be called by us adjacent. I'm sure you know what adjacent means. Adjacent means the one which is next to you, right? So if you ask me why do we call AB adjacent, so I will tell you that which side is next to angle A, just next to angle A. Next to angle A we have AB, that's why AB is adjacent. But if somebody would argue that no, next to angle A there is AC as well, so why is AC not called adjacent? AC is not called adjacent because it is the longest side of your right angle triangle, which is known as hypotenuse. Hypotenuse, right? So AC is hypotenuse, AB is adjacent. Okay, what about opposite side, which they are calling perpendicular? The opposite side or the perpendicular side is opposite to angle A. Opposite to angle A there is BC. So this is opposite, right? So they call this opposite side as perpendicular, and they call this base they call the adjacent side to angle A as the adjacent side, and hypotenuse is known as hypotenuse in both our you can say languages. So these are two different languages which we are referring to. We will rely on the language which I'm giving you, that is the language of opposite and adjacent, not perpendicular and base. And there is a specific reason behind it. The reason being that it is very when you call it perpendicular, you always, when you think about perpendicular line, when you close your eyes and imagine a perpendicular line always comes to your mind as a vertical line. But in trigonometry, it is not always so. For example, the next example we'll take. The angle of reference over here is C. Now, they are saying perpendicular is AB. Now the perpendicular has changed. So perpendicular is that side which is opposite to the angle of reference. See, this side is opposite to the angle of reference, that is AB. So they are calling it perpendicular, but the mistake which common mistakes which generally students make is they take AB as base, because base is generally what we think of as uh, horizontal line. Okay, but AB is perpendicular, it's not horizontal line. So you can make a mistake of taking AB as a base. That's why I don't prefer calling it perpendicular. I will call it opposite. Okay, because it's right opposite to angle C. And what about BC? So BC is the adjacent side to the angle of reference. That's why I'll call it adjacent. Here they have called base as BC. See, it's a vertical line and they are calling it base. Doesn't it sound little absurd? So first thing is you get used to the terminology which I'm giving you. Okay, so that's the uh, first difference of my technique versus your textbook or your teacher's technique. Okay, so my terminology includes three sides, one of which is adjacent, the second is opposite, and the third is hypotenuse. Now, with the help of this adjacent, opposite, and hypotenuse terminology and the angle of reference given over here as alpha, we are going to find which is the adjacent side, which is the opposite side, and which is the hypotenuse side. Okay, the adjacent side to alpha is QR. The adjacent side to alpha is QR. The opposite side to alpha is PQ. Sorry, PQ is the opposite side. And the hypotenuse with respect to alpha is PR. This is the hypotenuse, right? So, what they call opposite as? They call opposite as perpendicular. See, perpendicular is PQ. And what do they call base as? The adjacent is base in their terminology. So, base is QR and hypotenuse is PR. And if somebody is comfortable with the textbook terminology of the sides, that is perpendicular, base, and hypotenuse, no problem. I will accept it. The only thing is you should not make any silly mistakes while showing which is the opposite side, which is the perpendicular side, which is the hypotenuse. You should not make any mistake while indicating perpendicular, base, and hypotenuse. If you are referring to textbook terminology regarding the names given to the sides of a right angle triangle, but in adjacent, opposite, and hypotenuse method, your uh, chances of making mistakes are very less, because adjacent and opposite are very obvious. Perpendicular and base are not so obvious. Okay, so I'm explaining my point of view in different ways, so that for you it is easier to make a choice. I'm giving you a choice over here whether to identify these sides as perpendicular, base, or opposite, adjacent. It's your choice now. Okay, I have explained what is adjacent, opposite, and hypotenuse, and I have also showed you what is perpendicular and base. Okay, so that was those were the sides of a right angle triangle. Moving ahead, we have notation for angles. To indicate an angle, any letter of English alphabet can be used. But in trigonometry, in general, the following Greek letters are used for noting or notation or indication of an angle. So these Greek alphabets are theta, phi, or sometimes known as phi, alpha, beta, Some people they call it beta also, beta or beta, gamma, etc. So these are the Greek letters, Greek alphabets, which are used for the notation or indication of angles in a right angle triangle. Always remember that the angle of reference, which is denoted by these Greek letters, is always an acute angle. In a right angle triangle, you know that one of the angle is right angle and the other two angles are acute angle. So the angle of reference which we are referring to as of now is the acute angle only. Okay. Now let's talk about trigonometrical ratios. Before going there, I would like to ask you, in any right angle triangle, let's say triangle ABC, let's say in triangle ABC, in triangle ABC, how many sides do we have? How many sides do we have in triangle ABC? In triangle ABC, we have three sides: AB, BC, and AC. AB, BC, and AC. Okay, so we can make a ratio of these three sides in 6 different ways. Three sides can be arranged in a ratio in 6 different ways. If you understand what I mean, I'll show you. Okay, so there are three sides, as I told you. These three sides can be arranged in the form of a ratio in 6 different ways. So there can be 6 ratios comprising of these three sides. Let me show you how. The first ratio can be AB upon BC. Second ratio can be AB upon AC. Third ratio can be BC upon AC. Next ratio should be BC upon AB, the reciprocal of the first ratio. Fifth ratio should be AC upon AB, and the last ratio should be AC upon BC. Okay, so this is how you can get 6 different combinations of ratios out of the three sides of a right angle triangle. And since three sides of a right angle triangle can be arranged in 6 different ratios, and uh, we are studying the chapter of trigonometrical ratios, remember, so we can say that the ratio between the lengths of a pair of two sides of a right angle triangle is called a trigonometrical ratios. Right? What is the trigonometrical ratios? It is the ratio between the lengths of two sides of a right angle triangle. So these ratios can be can be of different forms according to the arrangement of the sides of two sides of a right angle triangle. So basically we are looking at six ratios. We are looking at six trigonometric ratios. The three sides of a right angle triangle give six trigonometrical ratios, namely. So what are the names of these six trigonometrical ratios? The names are sine, cosine, tangent, cotangent, secant, cosecant. In short, these trigonometrical ratios can be written as sine, cos, tan, cot, sec, cosec respectively. Okay, sine, cos, tan, cot, sec, cosec. Sine, cosine, tangent, cotangent, secant, cosecant. These are the names of the six trigonometrical ratios. Now, which ratio is which one? So, they have given the formula for each ratio with the help of the figure, and they have showed you the meaning of each kind of trigonometrical ratio. Okay, so what I'm going to do is I'm going to teach you separately, because I told you, I gave you separate names for the sides of a right angle triangle. Okay, so according to the name which I had suggested, we can draw a right angle triangle. So we have triangle ABC, in which the reference angle would be C. Let's say C is the reference angle. Okay, So I'm going to give it a name theta. I'm going to call it by name theta. All right. So what will be sine theta? Sine of angle of theta. Okay, sine, that is the ratio, trigonometrical ratio with respect to the angle sine theta. Now when we write it in short form, we don't write this e, so we just write sine of theta. Okay, now what is the formula for sine of theta? Now sine theta, the formula for sine theta can be remembered by a simple mnemonic which I'm going to show you, and the mnemonic is SOHCAHTOA. Very funny, right? So ka toa, SOHCAHTOA. Okay, what is this SOHCAHTOA? So in this SOHCAHTOA, you have to remember it like this, how I have written over here. S means sine, sine of a reference angle. Sine of a reference angle is equal to opposite upon hypotenuse. Sine is opposite upon hypotenuse. Okay, so let's find the value of sine theta in this particular triangle. What is opposite to angle theta over here? Opposite to angle theta over here is AB. What is the hypotenuse? The hypotenuse in triangle ABC is only 1. So there is no confusion about what is hypotenuse. Hypotenuse is AC. So sine of theta in triangle ABC, where the reference angle is C, which is theta, is opposite upon hypotenuse, which is equal to AB upon AC. Okay, the next trigonometrical ratio is cos theta. Cos theta is adjacent upon hypotenuse. Cos theta is adjacent upon hypotenuse. Okay, so we have adjacent upon hypotenuse A by H. What is the adjacent side to theta? The reference side is theta, and the adjacent side to theta is BC, and the hypotenuse is AC. The adjacent side is BC and the hypotenuse is AC. Okay, and the next trigonometrical ratio is tan theta. Tan, the full form of tan is tangent. Okay, so tan theta is equal to opposite upon adjacent. What is opposite to theta? Opposite to theta is AB and the adjacent side is AC. So tan theta is AB upon AC. Very interesting, right? So you must be wondering that the mnemonic is incomplete. The mnemonic gives you the trigonometrical ratios of only sine, cos and tan. Where is the other three trigonometrical ratios? Namely, I gave you the name, namely cotangent, secant and cosecant. That is cot, sec and cosec. So where is cot, sec and cosec over here? We had not mentioned them in the mnemonic, but in mnemonic we already have cot, sec and cosec. So the reciprocal of tan is cot. So I'm going to write cot over here. The reciprocal of cos is sec, and the reciprocal of sine is cosec. Okay, so cot theta, we can easily write cot theta as adjacent upon opposite. It is the reciprocal of tan theta. So what is adjacent to angle theta? Adjacent to angle theta is BC. What is opposite to angle theta? Opposite to angle theta is AB. See how the whole confusion related with perpendicular and base is eradicated while naming the triangles in this manner. The whole confusion is eradicated because there could be only one opposite side and only one adjacent side. One opposite and one adjacent makes it very easy to understand that how a trigonometrical ratio can be found out with respect to any reference angle. Any reference angle. You don't have to get confused between perpendicular and base. That's why I always refer to this particular you can say naming of these sides, that is opposite, adjacent and hypotenuse. Next trigonometric ratio is sec theta, and sec theta is hypotenuse upon adjacent. Sec theta is hypotenuse upon adjacent. So what is hypotenuse? Hypotenuse is AC, and what is adjacent? Adjacent is BC. That is sec theta, that is the value of sec theta. All right, what is the next trigonometric ratio? We have cosec theta. Okay, what is cosec theta? Cosec theta is hypotenuse upon opposite. Cosec theta is hypotenuse upon opposite. What is hypotenuse? Hypotenuse is AC and opposite is AB. So cosec theta is AC upon AB. Hypotenuse upon opposite, AC upon AB. Great. So we have got all trigonometric ratios, all 6 trigonometric ratios with respect to angle theta. But if at all I change my reference angle to angle A, will this trigonometric ratios have the same value? No, they will not. If I change my reference angle to angle A, suppose this is the reference angle alpha, and now if I find sine alpha, just for the for your understanding I'm showing you this. Now if we find sine alpha is opposite upon hypotenuse. Now let me ask you, what is opposite to the angle alpha in triangle ABC? What is opposite to angle alpha? Opposite to angle alpha we have BC. And what is hypotenuse? Hypotenuse is AC. So sine alpha in this case becomes BC upon AC. What was sine theta earlier when the reference angle was something else? Sine theta was AB upon AC and sine alpha became BC upon AC. So same trigonometrical ratios, same triangle, but different reference angles. So if you change your reference angle, your trigonometrical ratio will also change. Okay, so that's one of the very important you can say insight which you will find when you deal with trigonometrical ratios. Okay, now as I taught you the mnemonic, that is SOHCAHTOA, I hope you understood what is SOHCAHTOA. So is SOH, sine is opposite upon hypotenuse, Ka is CAH, cos is adjacent upon hypotenuse, TOA is tan, which is TOA, which is tan is equal to opposite upon adjacent, and cot, sec and cosec are respectively the reciprocal of tan, cos and sine. Tan, cos and sine. Okay, so we've got all the trigonometrical ratios. Now the question remains that how they have done it in the textbook, what they have found it in the textbook. So in the textbook I will give you another mnemonic if you want to go by textbook. If somebody says that नहीं मेरे को ये opposite और adjacent नहीं करने का है, मेरे को जो टेक्स्ट बुक में बोला है, मेरे को जो टीचर ने बोला है, स्कूल टीचर ने. अच्छा, और एक डाउट माइंड में आता है बच्चों के कि माय स्कूल टीचर्स हैज़ दे हैव टॉट मी इन सम डिफरेंट मैनर एंड दे हैव नॉट यूज्ड दिस mnemonic which you are saying. ठीक है, they have used perpendicular and base. They are sticking with the textbook. Although we have discussed the demerits of using perpendicular and base, they want to stick to perpendicular and base. So what should we do? I say nothing changes. Okay, you have to make a choice. I'm giving you a choice. If you are comfortable with opposite adjacent terminology, use that. If you are comfortable with perpendicular base terminology, choose that. No problem. Use that. Be comfortable. Okay, but only thing is be confident in whatever you choose and whatever method you use. Be confident in that. So I'm going to give you some more mnemonics for remembering the formulae for trigonometrical ratios involving these terminologies, involving perpendicular, base and hypotenuse. Okay, so the terminology goes like this: sine, cos, tan. SCT will remain as it is. PBP, HHB, PBP, HHB. So there are some you will find on internet, and many students, you know, they have figured out a way for remembering this PBP HHB. So what is this PBP HHB? So you can remember it like this. See, this is perpendicular upon hypotenuse, this is base upon hypotenuse, and this is perpendicular upon base. I already told you perpendicular in our language means opposite and base in our language means adjacent. Okay, so you can use accordingly. But what is the mnemonic associated with this? Like this is SOHCAHTOA. Okay, SOHCAHTOA is very easy to remember. But what about PBP HHB? PBP HHB, you can remember it as Pandit Badri Prasad Har Har Bhole. Very funny, right? Really funny. Pandit Badri Prasad Har Har Bhole. PBP HHB. There is one more. There's one more. Pakistan Bhukha Pada. Hindustan Hara Bhara. P for Pakistan. I know it's very funny. I know, but this is really easy to remember, and you will remember it till long time if you choose to use perpendicular and base terminology. Okay, Pakistan Bhukha Pada PBP, Hindustan H Hara H Bhara B, PBP HHB. There is one more, and this is really funny. So you can share it with your dad. Only the risk of getting slapped from your dad is yours. Okay, don't take my name. But this is created by some really clever students, not by me. Okay, so please don't put my name. I don't even recommend this method of terminology of naming the sides. So this is not me. Okay, this is not created by me. The last one is Papa beer pilado, ha ha beta. I just want to see your reactions. Papa beer pilado, ha ha beta. PBP HHB. ठीक है? So it's up to you. These are the mnemonics, and these will help you remember the formulae for finding different trigonometrical ratios. Okay, once you are comfortable with finding the formula for different trigonometrical ratios, it's going to be very easy for you guys to solve any questions based on trigonometry. Okay, all right, let's go ahead. Just a moment. Yeah, so nowadays I use this mic which I clip onto my beard hair, and that's really weird. Okay, great. So I'm all ready. Okay, great. So as you can see, let's take an example of sine. So sine is p by h. Okay, according to this diagram, p by h is bc by ac. Do you see bc by ac over here? Yes, so that's very easy to remember. And likewise, you can apply the formula, that is PBP or SOHCAHTOA to any triangle, any reference angle, and you get the uh, particular trigonometrical ratio. Okay, so one more last thing which we have is each trigonometrical ratio is a real number and has no unit. Each trigonometrical ratio is a real number and it has no unit. Each trigonometrical ratio is just a number. इसके आगे कोई unit नहीं होता है, meters या centimeter, कुछ नहीं, because it's a ratio of two similar quantities. So it has no unit, it is just a number. Okay, so we are ready to begin. Let's, before beginning, just see how many solved examples we are going to do. We are going to do 1, 2, 3, 4, 5 in the first part, and then continuation 6, 7, 8, 9, 10, 11, and then there are some reciprocal relations, and from 12th we'll move ahead, and we have around 15 solved examples in the whole chapter. So let's target to finish this chapter in a single video, and we can definitely do that. Yeah, all right, okay, great. Let's start, let's begin. So that's the first question which we have. Okay, so we have answers as well for us to check. From the given figure, find sine A, cos C, tan A, cosec C, sec square A minus tan square A. So this will be sec square A. Okay, and just mention over here sec square A minus tan square A. Here there is A is not written. Okay, that's why I'm just mentioning it over there. Okay, so we have a triangle in which we have AB, we have AC, we don't have BC. So I think we should first find BC using Pythagoras theorem. So in triangle ABC, angle ABC is 90 degree. Angle ABC is 90 degree. So by Pythagoras theorem, by Pythagoras theorem, we can say that AC square is equal to AB square plus BC square. AC square is 13 square, which is equal to 5 square plus BC square. 13 square is 169 minus 25 is equal to BC square. So BC square is equal to 144. So BC is equal to under root of 144. So BC is equal to 12. BC is equal to 12. Okay, so now we have found BC. Now let's focus on our trigonometrical ratios. The first trigonometrical ratio we have to find is sine of angle A. Now this is the first time I'm going to show you how to find sine of angle A. So this is our reference angle, angle A, and sine, according to the mnemonic which I gave you earlier, that is so ka toa. So I'm just going to write it here for our reference, ka toa. So ka toa. Okay, so what is so? So is opposite upon hypotenuse. Okay, so is opposite upon hypotenuse. What is opposite to angle A? Opposite to angle A is BC. What is hypotenuse? Hypotenuse is AC. So BC upon AC. What is BC? BC is 12. What is AC? AC is 13. So sine of angle A is 12 by 13. See the answer? Absolutely correct. Easy? Okay, let's go to the next. Cos of angle C is adjacent upon hypotenuse. Ka. You see over here, ka, cos, C, adjacent upon hypotenuse. So adjacent upon hypotenuse, mnemonic helps you there. What is adjacent to angle C? Now the angle of reference is changed. It is C now. What is adjacent to angle C? Did someone tell AC? I'm afraid you're not right. AC cannot be the adjacent side because AC is the hypotenuse. Okay, hypotenuse cannot be adjacent. Hypotenuse is always hypotenuse. So BC. Yes, you are right. Adjacent side is BC upon hypotenuse is AC, and BC is 12, hypotenuse is AC, which is 13. So again 12 by 13. So sine of one of the angle equal to sine of the other angle. Sine of one of the angle is equal to cos of the other angle, and that is completely okay. See, this is not wrong. Okay, if you're thinking that I said that two trigonometric ratio of two angles in a same triangle cannot be equal, they will always be different. That is right, but these are two different trigonometric ratios. First trigonometric ratio was of sine, and the second trigonometric ratio was of cos, and that too of different angles, sine of angle A and cos of angle C, and that's why they have different same value. They may have or they may not have sometimes the same value. Okay, so don't worry about that. Okay, next, third one is tan of angle A. Tan of angle A is opposite upon adjacent. What is opposite? Opposite of angle A is BC. If you see, opposite of angle A is BC. Adjacent is AB. So BC upon AB. BC is 12 and AB is 5. Okay, so 12 upon 5. So tan A is 12 by 5. Absolutely correct. Let's go to the next question. Question number 4. We have cosec C. Cosec C. Alright, so what is cosec? You don't see cosec over here, but as I told you, the reciprocal of tan is cot, the reciprocal of cos is sec, and the reciprocal of sine is cosec. Okay, so cosec is nothing but the reciprocal of sine, that is hypotenuse upon opposite. Hypotenuse upon opposite is cosec, cosec of any angle. What is the hypotenuse? Hypotenuse is AC, and what is the opposite? Opposite of angle C, opposite of angle C is AB. AC upon AB. What is AC? AC is 13. What is AB? AB is 5, so 13 upon 5 is absolutely correct. Number 5, we have sec square A minus tan square A. Now this is going to be a little long. Great. So let's talk about sec and tan. What is sec? Sec is reciprocal of cos. Sec is reciprocal of cos, that is hypotenuse upon adjacent. Hypotenuse upon adjacent the whole square minus tan is opposite upon adjacent the whole square, right? So hypotenuse is 13 by adjacent of angle A is hey, let me first write the names. That is right. So hypotenuse upon adjacent, that is AC by AB, AC square by AB square, minus opposite upon adjacent. Opposite of angle A is BC by adjacent, BC square by adjacent, which is AB square. Okay, so we have AC square minus BC square upon AB square. Now, if you want, you can put the values of AC, BC and AB. AC in the triangle is 13 square minus BC is 12 square upon AB. AB is AB square, so AB is 5 square. Okay, so 13 square is 169 minus 144 upon 25. That is 25 upon 25, which is 1. So sec square A minus tan square A is 1. So that's your first square relationship for you. Sec square A minus tan square A is the square relationship. I'm going to talk about square relationship, but those who are interested, those who really want to note down the formula for square relationships, please note it down. I'm going to give you 3 square relationships. 3 square relationships. Sine square A plus cos square A is equal to 1. Then 1 plus tan square A is equal to sec square A, and one plus cot square A is cosec square A. Right, so these are square relations which we are going to use later in the chapter. Okay, so that was question number 1, and I think by now, by looking at the whole question and the pattern, it should have become very clear in your mind that what is trigonometry all about, and what is what are the trigonometrical ratios, what are their values, how to find their values, and how we can relate the trigonometrical ratios with the different reference angles in right angle triangle. All right, okay, so next figure, we don't have a figure, we have just a question. Question number 2. In a right angle triangle, if angle A is acute and chord of angle A is 4 by 3, find the remaining trigonometrical ratios, and I should complete this statement by writing of angle A or with respect to angle A. So you have been given cot A, you have to find sine A, cos A, tan A, sec A and cosec A. Let's see how to find it. Okay, so let's first draw a right angle triangle in which our angle of reference is angle A. Okay, so let me take this as A, B and C. This is our angle of reference, and we know that chord of angle A is 4 by 3. Okay. So applying SOHCAHTOA, we know that tan is opposite upon adjacent and cot is reciprocal of tan. So cot of angle A is adjacent upon opposite. Now what is adjacent to angle A? Adjacent to angle A is AB and opposite to angle A is BC, which is equal to 4 by 3. So therefore AB upon BC is equal to 4 by 3. So let AB is equal to 4x and BC is equal to 3x. Therefore, in triangle ABC, angle ABC is equal to 90 degree. Therefore, AC square is equal to AB square plus BC square by Pythagoras theorem. Okay. So AC square, do we know AC square? No, we don't know. Is equal to AB square plus BC square. Okay, AB square. What is AB? AB is 4x. 4x the whole square plus BC square. BC is 3x. 3x the whole square. So AC square is equal to 16x square plus 9x square. So AC square is equal to 25x square. So AC is equal to root 25x square, which is 5x. So what we did, we found the value of AC. Let's write all the values which we found over here. So AC is 5x, AB is 4x and BC is 3x. So at least we got to know that what are the ratios of the lengths of the sides. Not the actual length of the sides because we do not know what is the value of x. Okay, let me just make some space over here. Okay, so this is 4 by 3. Okay, so we got to know that what are the sides of this triangle. Now it's very easy to find sine, cos, tan, sec and cosec, the remaining trigonometrical ratios. So sine of angle A is opposite upon hypotenuse. So opposite is BC, hypotenuse is AC. So BC is 3x, hypotenuse is AC, which is 5x. So this is 3 by 5. Okay. Then comes cos A, which is adjacent upon hypotenuse. So the adjacent of angle A is AB upon hypotenuse is AC. AB upon AC is 4x by 5x, which is 4 by 5. Okay. Tan A is equal to opposite upon adjacent. Opposite is BC, adjacent is AB. BC upon AB is 3x by 4x, which is 3 by 4. Okay, then cot A is given to us. We have to find sec A, which is reciprocal of cos A. Why to do anything else? We can just simply use reciprocal relations. So sec A is reciprocal of cos A, that is 1 upon 4 by 5, which is 5 by 4. And cosec A is reciprocal of sine A, that is 1 upon 3 by 5, which is 5 by 3. Okay, so these are all the remaining trigonometric ratios, remaining 5 trigonometric ratios. So this is the way you find remaining trigonometric ratios if one of the trigonometrical ratio according to a relating to a triangle or referring to a triangle is given to you. Let's go to the next question. Given 13 sine A is equal to 12. 13 sine A is equal to 12. So sine A is equal to 12 by 13. Sine A is equal to 12 by 13. Okay. So what we have to find? We have to find sec a minus tan a, and we have to find 1 by cos square a minus tan square a. Okay. So let's see. Sec a minus tan a. First we have to draw a triangle. In which angle A should be the angle of reference. So I will write it like this: A, B, C. This is your angle of reference. Alright. So we have to find sec A minus tan A. See, sin A is given to us, and if we apply SOHCAHTOA, SOHCAHTOA, sine is opposite upon hypotenuse. Opposite of angle A is BC. So wait, I can write it as opposite upon hypotenuse. Therefore, opposite upon hypotenuse is 12 by 13, which implies opposite is BC and hypotenuse is AC, which is 12 by 13. Therefore, BC is equal to 12x and AC is equal to 13x. So BC is 12x, AC is 13x, and we do not know AB. So if you have to find anything, we have to find AB first. So AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. So AB square we don't know. BC square is 12x the whole square and AC square is 13x the whole square. So AB square plus 144x square is equal to 169x square. So AB square is equal to 169x square minus 144x square. ठीक है, so AB square is equal to 25x square. So AB is equal to root of 25x square, which is 5x. Okay, so AB is 5x. Let me just write it over here so that we know that AB is 5x. Okay, now we can find whatever we want. So if we want to find sec A, see, sec is reciprocal of cos. So it is hypotenuse upon adjacent, which is 13x upon 5x. X cancels, which becomes 13 by 5. And we have to find tan A. So tan A is opposite upon adjacent. Opposite of angle A is BC. Adjacent to angle A is AB. So BC upon AB is 12x by 5x, which is x cancels, 12 by 5. So we have sec A minus tan A, sec A minus tan A, which is 13 by 5 minus 12 by 5, which is 13 minus 12 by 5. 13 minus 12 is 1 and 1 by 5 is the value of sec A minus tan A. Now what we have to find after this is the first answer. Okay, 1 by 5, which we have got over here. Okay, did we check all the answers in the previous question? 3 by 5, 4 by 5, 3 by 4, 5 by 4 and 5 by 3 are all correct. Okay, so I just forgot to check the answer, that's why I did that. And let's go to the second question. Okay, so in the second question, we have to find 1 upon cos square A minus tan square A. 1 upon cos square A minus tan square A. Now, before we go ahead, let me tell you that 1 upon cos square A can be written as 1 upon cos A the whole square minus tan square A. And we know that 1 upon cos A is sec A. Okay, so sec square A. 1 upon cos A is sec A the whole square, which is sec square A minus tan square A. And did I discuss square relations with you? Yes, I think I gave you a little glimpse in a few minutes ago. But okay, don't worry about square relations right now. Let's worry about what is sec A and tan A. Sec A, we already know the value of sec A, which is 13 by 5. So 13 by 5 the whole square minus tan A is 12 by 5 the whole square. Okay, so this is 169 by 25 minus 144 by 25, which is 169 minus 144 by 25, which is 25 by 25, which is 1. So the value of sec 1 by cos square A minus tan square A, or sec square A minus tan square A, is 1. Okay, so that's the second answer. Right? Very nice question. We are getting the full idea about how to apply the concept of trigonometry in the questions, and that is what we do in the classroom. So this is like a hands-on experience of trigonometry which you are getting, which you can apply directly while solving the exercise. Let's go to the next question. In the given figure, ABC, in a given figure, ABC in a right angle triangle is a right angle triangle actually, right angled at B. So this should be is. ABC is a right angle triangle at B, okay. BC is 5 centimeter, AC minus AB is 1 centimeter. Okay, so AC is greater than AB, na? AC is greater than AB. That means if AB, which is smaller, is x, AC will be x plus 1. So we can begin with this statement. Let AB be x centimeter. Therefore, AC minus AB is equal to 1 centimeter. So AC minus x is equal to 1 centimeter. So AC is equal to 1 plus x, yeah, x plus 1 centimeter. So we got all the three sides. Great. What next? Find the value of cosec A and cos A. Cosec A and cos A. Great. So this is angle A, which we are taking as reference angle, and we have to find cosec A minus cos A. But before finding cosec A and cos A, cosec A and cos A, sorry. So before finding cosec and cos A, we have to find the length of the sides of the triangle. So that we can find by using Pythagoras theorem. So by Pythagoras theorem, we can say that AC square is equal to AB square plus BC square. So AC square is x plus 1 the whole square. AB square is x square and BC square is 5 square. So this is x square plus 2x plus 1 is equal to x square plus 25. Okay, x square is cut over here. So what we can do is 2x is equal to 25 minus 1 we can write. So 2x is equal to 24. So x is equal to 24 by 2. So x is equal to 12 centimeter. X is equal to 12 centimeter. Okay, so now once we have got the value of x, what next can we do? Okay, so we can say that therefore AB is equal to x, which is 12 centimeter, and AC is equal to x plus 1, which is 12 plus 1, which is 13 centimeter. So we got the length of every sides. Okay, so BC is 5, AB is 12, and AC is 13 centimeter. Now we can find cosec A and cos A. So SOHCAHTOA, so ka toa, that's my mantra, because I'm always going to use that. I'm always going to be dependent on that. Cosec A, cosec is the reciprocal of cos, so that is hypotenuse upon adjacent. I'm sorry. Cosec is the reciprocal of sine, right? So that is hypotenuse upon opposite. Cosec is the reciprocal of sine. What is hypotenuse? AC. And what is opposite to angle A? BC. Reference angle is A, okay? So AC is 13 and BC is 5. So cosec A is 13 by 5. Great. So we found cosec A. What about cos A? Cos A is adjacent upon hypotenuse. Cos A is adjacent upon hypotenuse. So adjacent to angle A is AB and hypotenuse is AC. So that is 12 by 13. That is 12 by 13. So right, we got 13 by 5 and 12 by 13 as the value of cosec A and cos A. Right? So that's okay. 13 by 5 has been converted into mixed fraction over here. 2, 3 by 5, which is no problem. Okay, so this is how you solve this question. Very easy. Let's go to the next question. Okay, well, we have got two right angle triangles over here. So for the given figure, cos alpha, this is alpha, okay, not q. This is not a or q, this is alpha, this is beta. Cos alpha is 5 by 13 and cos beta is 3 by 5. Find the length of BD. Very easy, very easy. So in triangle ABC, cos of alpha is equal to, cos is adjacent upon hypotenuse, so ka tova ka, and adjacent of alpha is BC upon hypotenuse is AC, right? So BC by AC is equal to, BC by AC is equal to 5 by 13. 5 by 13. So let, see, do we know BC or AC? No, we don't know. So let BC is equal to 5x and AC is equal to 13x. Therefore, by Pythagoras theorem, AC square is equal to AB square plus BC square, and AC square is 12 square is equal to AB square, which is AC square is 13x the whole square. I'm sorry for that. 13x the whole square is equal to AB square, which is 12 square, plus BC square, which is 5x the whole square. So we can solve this and find the value of x. So 169x square is equal to 144 plus 25x square. So 169x square minus 25x square is equal to 144. So we have got 144x square is equal to 144. 144 gets cut from both the side. X square is equal to 1. So x is equal to plus minus 1. X is equal to plus minus 1. Now understand that x cannot be minus 1. Why? Because if you multiply x with 5 or 13, you will get minus 5 and minus 13, and length of the side of a triangle can never be negative. Therefore x will be taken as 1 only, and therefore we can say that BC is equal to 5x, that is 5 into 1, which is 5 centimeter, and AC is equal to 13x, which is 13 into 1, which is 13 centimeter. Right? So we have got BC and AC. All right. Okay. So now what? Okay. Now we will consider, since we have found the length of the sides of AC and BC, see AC is 13 and BC is 5. Now we'll target the other triangle, that is triangle CDE. So in triangle CDE, by Pythagoras, I'm sorry. In triangle CDE, cos of beta is equal to 3 by 5. Cos of beta is 3 by 5. So cos is adjacent upon hypotenuse, which is equal to, what is adjacent to beta? CD. What is the hypotenuse? CE. CD upon CE is 3 by 5. So let CD is equal to 3y, I'm just taking as a ratio, y is a multiple, and CE is equal to 5y, right? And we know DE is 8 meter, therefore by Pythagoras theorem, we can say that CE square is equal to CD square plus DE square. Okay, CE square is equal to CD square. I'm sorry, I know the value of CE and CD. CE is 5y the whole square, which is equal to CD, which is 3y the whole square, plus DE, which is 8 square. So 25y square is equal to 9y square plus 64. So 25y square minus 9y square is equal to 64. So 16y square is equal to 64. 16y square is equal to 64. So y square is equal to 64 by 16. So y square is equal to 4 and y is equal to under root of 4, which is plus minus 2. But will not take the minus sign, the same reason why I gave you earlier. Therefore CD, which is 3y, which is 3 into 2, which is 6 centimeter, and CE, which is 5y, which is 5 into 2, which is 10 centimeter, and we already know that DE is 8 centimeter. Okay, so these are all the three sides of right angle triangle CDE, which is 6, 10 and 8. This is 10 and this is 6. So we have to find the length of BD. BD will be BC plus CD. We know BC is 5, CD is 6, so that is 11 centimeter. 11 centimeter. That's your answer. Did you understand? Very interesting, right? Cool. So that is your trigonometry chapter 1 part 1. Chapter 1 part 1, yeah. First chapter of trigonometry and part 1. So we are going to start with part B. I just want to show you the textbook and the kinds of questions which we are going to face. Let's check it out. Okay, so the most of the questions in this chapter are in part B. Okay, in part B there are not very different questions, similar kinds of questions, but I would like to complete this part in the next part of the video, that is second part of this video. I was thinking to make one part of the whole for the whole chapter, but the questions are not very small, they are big questions, and I believe that you know you have to have some gap or some you can say some breather to understand what you have been taught. So I will stop this video over here. You watch this video and complete exercise 22A. There are 20 questions in that. So that will be your challenge, your task. You start with that and I will follow with the second part of this video, which will be the final part, but it's going to be big because there are many questions. Okay, so I'll see you in the next video. Bye bye.